Hello students, welcome in chemistry classes. I am Priyanka Jain and you are watching the videos of analytical chemistry. In our last lecture, we have studied about the analytical chemistry's very important topic, atomic absorption spectroscopy, and we have cleared the several questions that has been asked in the CSIR net and GATE exam. Okay, now there is one more important topic, a very important topic, Beer-Lambert's law, because several questions numerical questions are asked from this topic, so we are seeing this topic in a very short manner. We will see all the aspects, it means all the type of formulas, limitations, whatever you need we will see in this lecture, and then at the same time we will also solve the questions that has been asked in the CSIR net exam. Okay, so let's start our video. Alright, so firstly see a little bit look on the what is Beer-Lambert's law. Actually what happens, suppose we are taking a monochromatic light. Okay, if we have a source of monochromatic light and we are passing this light through a cell. This cell has the length L. Okay, the length of the cell is L and its concentration is C. The solution that is present in the cell has the concentration C. Okay, now the intensity of the radiation is I naught in the initial state. When this radiation pass through it, the intensity of it will decrease. It remains I because some of the light is being absorbed here. Okay, and this is detected by the detector. This is the detector. So actually, according to the Beer-Lambert's law, what is said? The decrease in intensity of incident light with thickness L is directly proportional to incident light. It means if we are taking it in the mathematical form, what we can write, logarithm of I naught upon I is equal to epsilon CL. Now what is epsilon here? Epsilon is called molar extinction coefficient, and C is here concentration of the solution in moles per liter, and then L. L is the length of that path, thickness of the cell, that is taken in centimeter. Okay, actually this ICL is represented as absorbance. A is called epsilon CL. This A is called the absorbance or absorptivity. Sometimes we use one more pronunciation for it, that is optical density. So in question papers, either you can see absorbance or you can see optical density. Both the things are same. You can see either absorbance or optical density. Both is represented by A. So A is equal to epsilon CL. Okay. Now there is one more term that is used, that is called transmittance. Actually, transmittance is just the opposite of absorbance. In absorbance, we are seeing the absorbed light. In transmittance, we are seeing the transmitted light. So actually, the transmittance is the intensity of the transmitted light divided by the intensity of the initial light. When we are seeing this both equation, this one, these equations are very much important. This equation and this transmittance can be denoted by T. Okay, so this is the second equation that you are seeing. Actually, these equations are quite important. Okay, so if we are matching these two equations, what we are getting? We are getting transmittance T is equal to 10 to power minus absorbance. Or we can write it T is equal to 10 to power minus epsilon CL. Any of the formula can be used when you have given the numericals. One more formula is log of T is equal to A. Minus logarithm of T is equal to A. Okay. And one more formula is absorbance is equal to 2 minus logarithm of percentage transmittance. If you have given percentage transmittance and you have to find out the absorbance, then you can use this formula. Okay, so all of these formulas are very much important and you should learn these all formulas so that you can do all the 2 marks and 4 marks questions. Now one more important thing that is asked is the deviation from the Beer-Lambert's law. Actually, what happens in Beer-Lambert's law, we plot a graph between the concentration C. Actually, in Beer-Lambert's law, we plot a graph between absorbance and the concentration of the solution. And we are getting the straight line. if the solution is following the Beer-Lambert's law, then we are getting the straight line. But actually we see the deviations in some of the conditions. Why we see deviation? First of all, we see the deviation when there is high concentration of solution. It means at higher concentration, when the concentration is greater than 0.1 m. When the concentration is more than 0.001 m, then in that conditions, what can happen? There may be several types of interactions, like solute-solute interaction, like solvent-solvent interaction, or there may be hydrogen bonding or any other type of the interaction there can be happen in this solution. So this affects actually the electron density of the analyte environment, and this whole thing affects the absorptivity. It means we can say at higher concentration the refractive index of the sample will change. Okay, so as a result of this the absorbance will change. Okay, so absorbance show a negative deviation. It means we will see a negative deviation in this graph. It means this will be like this. This is called the negative deviation. Okay, secondly, when we are using polychromatic radiation, actually in the Beer-Lambert's law, we see the monochromatic radiation, but sometimes we can use polychromatic radiation. And when we use this, then in this case also deviation will be seen. Similarly, if we are seeing here any type of association or dissociation, if in the solution there occurs any type of the association or dissociation between the solute molecules or between the solute solvent molecules, then in that conditions also we will see the deviation. So these are three conditions for the deviation. First is when our solution is at high concentration, when we have used the polychromatic radiation instead of monochromatic radiation, or if there is any type of the association or dissociation between the species, then in all that conditions we will see deviation from the Beer-Lambert's law. Okay, I think now the things are clear, and now we are solving the questions. Which type of questions are asked here? See here one question from CSIR June 2019. What is the question? Observe the following aqueous solution of some compound. All the measurements are made at same wavelength and same temperature. Okay, same compound we have taken here. Okay, so actually the molar extension coefficient will remain same. It means our epsilon value will be same. Okay, now we have given three different solutions. In solution A, the transmittance we have given 0.1 moles per decimeter cube. Using 1 centimeter cell is 0.5. Okay, it means for solution A, what thing we have given? We have given transmittance, that is 0.1 mole. For solution A, first thing we have given the transmittance, that is 0.5. Okay, and then we have given the concentration, that is 0.1 mole per decimeter cube. Okay, and then we have given the length, that is 1 centimeter. Now see the second solution, solution B, that we have given. For this solution, what thing we have given? Optical density is 0.5 decimeter cube is measured using 1 millimeter of cell. It means here we have given the concentration, that is 0.5 mole per decimeter cube. Okay, and then we have given the length 1 mm, and optical density we have to find out. Okay, and for solution C, what thing we have given? For solution C, we have given the transmittance of the solution is 0.1 m. It means we have given only the transmittance, that is 0.1. Now we have to find out the optical density, follow the order. It means for the three solutions we have to find out the optical density, it means absorbance, and then we have to see their order. Okay, let's do the question. So firstly for solution A, we have to find out. Here A we can find out very easily, that is logarithm of 1 upon transmittance. If you know the formulas, you can do all the things in a very good manner. So this will be equal to log of 1 upon 0.5, that will be equal to logarithm of 2. Okay, so this will be equal to 0.3010. Okay, now we have given the CL, so we can find out the epsilon. Okay, we know epsilon CL is equal to A. So epsilon will be equal to A upon CL. Okay, just put here the values 0.3010 divided by 0.1 into 1. Okay, so this value comes 3.01. Okay, now we know that our optical density is this one, 0.3010. Okay, now for solution B, we have given L and C. We don't know epsilon, but we had find out here the epsilon value. This is 3.01. Okay, so our epsilon is 3.01. Now we can easily find out value of A, that will be equal to epsilon CL. So it will be equal to 3.01 into 0.5 into 0.1. So this will be equal to 0.1505. Okay, now see solution C. Here in solution C, we have given only the transmittance. So A will be equal to logarithm of 1 upon T. So it will be equal to logarithm of 1 upon 0.1. It means logarithm of 10. So this value will be equal to 1. Okay, now we know the three values. So what we can say, this value is highest one. It means C will have the highest value, then will be for A, and then will be for B. This will be the order. So let's match this order. See here, in option number D, we have given C, A, B. So this is the right answer. Okay, let's do the next question. See here the second question of CSIR net June 2012. Using Q weight of 0.5 centimeter path length. It means we have given this is the L. A 10 to power minus 4 m solution, that is C, of chromophore shows 50% transmittance. This is T. Okay, percentage transmittance we have given at certain wavelength. Molar extinction coefficient of chromophore at this wavelength is. So I have told you about this formula in which we have given the percentage transmittance. So we can use that formula directly. A is equal to 2 minus logarithm of percentage transmittance. So put here the value 2 minus log of 50%. Okay, so this will be equal to 0.3010. Okay, now A is equal to epsilon CL is equal to 0.3010 is equal to epsilon CL. So put here value 0.3010 is equal to epsilon into 10 to power minus 4 into 0.5. So our value of epsilon comes 0.3010 divided by 10 to power minus 4 into 0.5. So this comes around 6020 per mole per centimeter. Okay, so this will be your value. Now you can match option number D, 6020 per mole per centimeter. This is your answer. Let's see the next question. This is the next question. See here, December 2012 question. Appropriate reason for deviation from form of Beer's law among the following are. First, we have given monochromaticity of light. C, B have given very high concentration of analyte. C, we have given association of analyte. And D, we have given dissociation of analyte. So what are the reasons for the deviation? Okay, and I have told you there are three basic reasons. First is very high concentration. Second is polychromaticity. And third reason is association and dissociation. So just you will have to see. In option number A, we have given monochromaticity of light. But actually, if we are taking monochromatic light, then there will be no deviation. We are getting straight line. So this is wrong. Very high concentration is true, association is true, and dissociation is true. So we can say B, C, D is the right answer. Option number B is the right answer. Let's see the next question. Okay, let's see the next question from June 2015's question paper. What is the question? The intensity of light beams decreases by 50% when it passes through a sample of 1 centimeter length. The percentage of transmission of light passing through same sample but of 3 centimeter path length. Okay, we have given 4 options. Now we know. What is the formula for this? We know the formula log of 1 upon T is equal to absorbance, that is equal to epsilon Cl. Okay. So from this we can find out our values. Log 1 upon T1 will be equal to epsilon Cl1 and log 1 upon T2 will be equal to epsilon Cl2. Okay. Now you can divide equation 1 by equation 2. So we are getting log 1 upon T1 upon log 1 upon T2 is equal to epsilon Cl1 upon epsilon Cl2. We can write it like this: log T1 upon log T2 will be equal to L2 upon L1. Okay. So from this, now I am writing here. So see, log of T1. We have given log of T1. So log of T2 will be equal to L2 upon L1. Values you can put here 3 upon 1 logarithm of T1. Okay. So now you know T1 is given to us, that is 50%. It means 50 divided by 100. So this value comes 3 log 0.5. Okay. So from this you can calculate the value. If you are calculating, you will get T2 will equal to 12.5%. Okay. So this will be your answer. You can match it. Option number D is the right answer. Okay. So in this way you have to do the questions based on the atomic absorption spectroscopy. Okay, if you want some more questions, I can give you. You will have to comment me. If you are liking the videos, please share this. Please subscribe our channel and please comment us. Thank you.